Okay. Still thinking? Okay. Later I'll update, okay? Right. Okay, right. So last time we have discussed about the first method in order to determine the reaction order, which is by using the initial rate method. Okay, right. So for this method, you will be given a set of data. Okay, and then you have to determine the order with respect to each reactant in the reaction. If, let's say we have A and B as a reactant, you have to use the data given so that you can find out the order of the reactant with respect to each reactant. Okay, right. So basically, you are going to choose experiment ataupun reaction experiment having one reactant being kept constant and the other one will be varies. And that is for with respect to that reactant, for example A. And then if you are going to solve for B, that means you are going to make sure that the concentration of A should be kept constant, while concentration of B should be varies. Okay, right. So we have done checkpoint 3. We have discussed this checkpoint 3. Okay, and we have checkpoint 4. Have we discussed checkpoint 4, guys?
Not yet, madam.
Okay, all right. So I hope that everybody has completed this checkpoint, and I assume that everybody has done it. So let's discuss the answer. Okay, all right. So for this question, uh, consider the following reaction and the data given in the table. Determine the rate law. Okay, determine the rate law. Oh, sorry. Determine the rate law for the reaction and also calculate the rate constant K. All right, so this question is almost the same as the previous question that we had. It's just that for this one, you have to write the rate law. Previously, previously the question did not ask you to write the rate law. Just find the order of each with respect to each reactant. Okay, but this time around, you have to write the rate law. But the process will still be the same. Before you could write the rate law of the reaction, you have to know the order of the reaction, the order of with respect to each reactant. Okay, then only you can write the rate law. I'm not talking about the general rate law. The general rate law means you have unknown. Okay, but the one that the question wants is the one that the order, okay, the order has already been determined. Okay, and then from there you are going to calculate the rate constant K. So this is pretty much the same as the previous question just now. You may use any of the data, any of the data from the experiment given. Okay, let's say you go for experiment 1, that means you have to use all the data from experiment 1. You cannot just simply campur aduk, mix up the data. Don't do that. If you choose to calculate using experiment 1, that means the concentration of NH4 plus should be from experiment 1, and O2 minus also should be coming from experiment 1, and also the initial rate. Okay, don't just simply mix up everything. Don't do that because you won't get the answer. Okay, if you check again, if you try to calculate the rate constant using experiment 1, and then try to calculate using the data from experiment 2, experiment 3, you should get the value for the rate constant. Okay, the value should be almost the same because we are calculating for rate constant. For the constant, we are calculating for the constant. So the value should be constant by right, kan? Okay, let's check the answer, okay? Okay, so we're gonna check for NH4 plus first. If we are going for NH4 plus first, that means we have to choose experiment having NO2 minus having the same concentration. Okay, but first you have to write the rate law with respect to experiment 3. So see this, and with respect to experiment 1. So basically they both have the same general rate law, M, N, M, N, because we are using the same reaction. It's just that the concentration are being varied. That is all. Okay, so the rest kita remain constant. So this is the general rate law for experiment 3. This is general rate law for experiment 1. As you can see, K can be cancelled out. NO2 minus can be cancelled out as well because the value will be the same. Cancel out, cancel out. Buat yang ni, tunjukkan cancellation ni ya. Kalau tak, sebab dekat in our lecture notes, we don't have this cancellation. But by right, we should have. Because how do we know that, then how do we explain that suddenly the K and the NO2 dekat sini are now gone? Kenapa they gone guys tu? Because they are all being cancelled out. Okay, and then you are left with this one. When you factorize the M, so you will get this one. So we have this, the rate 3 over rate 2, okay, is equal to this one. Okay, and then second step is the step where you insert the data from the table. Okay, make sure that you insert the data correctly and then you solve it. Okay, and you will find out and you will determine that the M depending on the unknown that you've chosen. Let's say you want to use X dengan Y ke, M dengan N ke, A dengan B ke, doesn't matter. Okay, as long as it is representing the order of NH4 plus. Okay, all right, so the M is equal to 1. This is with respect to NH4 plus. Okay, all right. Next, okay, now with respect to NO2 minus, the same approach we apply for NO2 minus. Okay, so this time around, we're going to choose rate 2 and rate 1. Okay, all right, so finally, we have N is equal to 1. The ratio is, the M is equal to 1 and N is also equal to 1. Okay, all right, so that is the order for both of NH4 plus and also NO2 minus. Lastly, don't forget that you have to write the rate law. Make it a habit, okay, to write the rate law at the end of your calculation. Okay, all right, so if not, if somehow you still forget to write the rate law, that means you will lose this mark for the rate law. You will lose 1 mark for your rate law. Okay, right. Last, the rate constant. Okay, you may choose any data from the experiment. So from based on the data here, let's check which data, 1.35. Okay, so here we choose experiment 1. Okay, as the data. You may choose experiment 2, you may also choose experiment 3, doesn't matter. But guys, please make sure that you have unit. Okay, you need to have unit, especially when you are calculating for rate constant. Because secondly, okay, the method to determine the order of fraction is by using the unit of the rate law. If you are calculating for the rate law, of course lah, you need to have the unit. Okay, make sure yang mana yang kena cancel, yang tak, yang remain should be remain lah. Okay, alright. That is checkpoint 4. Next is checkpoint 5. This is past year's question. Okay, let's look at the question. The rate of reaction between bromate ion and bromide ion in terms of changes in concentration of reactant and product is given below. Okay, all right. So the data from 4 experiments are listed in the table below. So as you can see, we have 3 reactants, and then this is the differential rate equation. So most likely the question will be asking for equation. You have to write the equation, the balance equation for this reaction. Okay, remember last time I have advised you that make sure that you know how to transform from balance equation to this differential rate equation and vice versa, from differential rate equation to balance equation. Okay, all right, so we can predict that we have -3, negative here, that means we have 3 reactants, and from the data as well, okay, we have 3 columns that represent 3 reactants. Okay, we tengok, see, write a balance equation for the reaction. And lastly, if the rate of the above reaction is first order with respect to BrO3 minus and Br minus, see, soalan ni lain sikit. Even though we have 3 reactants, dah boleh terbayang dah kepayahan kita tu nak cari 3, bukan payah lah, banyak step lah, okay. Tapi, kita tengok soalan, okay. Instead of you have to find the order of each reactant, it's given, okay. It's already given in the question, but only for bromate and bromide ion. So both of them has first order reaction. First order for bromate and first order for bromide. What you need to calculate is the order of reaction with respect to H plus and write the rate law of the reaction. Okay, and write the rate law of the reaction. So how will you solve for this? Okay, how will you solve for this? Ideally, so kalau based on what we have learned so far, of course lah kita akan cari yang bromate dengan bromide ion dia sama. Betul tak? Which is 0.2, ni dia sama, ini dia tak sama pula. Sebab kita nak cari H plus kan. Kita pun akan cari lagi, ada tak 0.2, 0.1, 0.1. Yeah, number 1 and number 4. Okay, sama except for H plus and except for H plus lah. Okay, so that would be the ideal situation lah kalau based on what we have learned so far kan. You mesti akan tend to, okay, constantkan bromate dengan bromide and then find out yang H plus berbeza. So kita akan go for 1 and 4, experiment 1 and 4. That would be the ideal one. But, just nak bagi you, nak trigger lah kan. Trigger thinking sikit. Perlu ke kita cari dia tu sama? Is it necessary? Atau is this the only way for us to determine the order of reaction? Iaitu making sure that the reactant punya concentration for bromate and bromide should be the same? Mesti ke macam tu? Apa you guys rasa? Perlu ke macam tu? Panas pula. Ada tak yang terfikir? Memanglah, this is the normal way. Okay, first A macam biasa, you have to come up with the balance equation. So this is your balance equation from the differential rate equation just now. Okay, so A shouldn't be a problem. By right, it should not be a problem. Okay, you boleh senang-senang get 1 mark from that. Okay, B. Okay, this is the general equation. So this is known. This is already known. Okay, this given from the question, but this one kita kena determine lah. Okay, alright. So normally we would go for this kind of method, betul tak? We would go for this kind of method, this type, this way. But saya punya question nak trigger you punya thinking lah. Perlu ke kita mesti melalui cara ni. Sebab as you can see, we have all the unknown already except for Z. Kita hanya ada satu unknown je sekarang ni. The rest are all known value. So we have the rate, we have the, okay, K lah, katalah kita tak tahu K kan. Okay, kita tak tahu K. Tapi K will be the same kan. BRO3 minus, BR minus. Okay, perlu ke kita mesti 1 dengan 4? Boleh tak kita 2 dengan 3? Boleh tak guys?
Boleh.
Ha. 1 dengan 2, 2 dengan 3, 3 dengan 4. Boleh tak? Kena mesti juga 1 dengan 4? Soalan saya. Sebab you tinggal satu je yang kat sini yang nak kita cari. Yang unknown. Okay, the rest are all known value. So kalau you pilih 1 dengan 3 lah for example, you dah determine this one, you dah determine this one. K dengan K later still can be cancelled. Okay, K can still be cancelled. Now you have this value and you already determine the what is that called? The order for bromide and bromide. Okay, the order for bromide and bromide. And the rate is also known. Boleh tak you cari value using other than rate 4 and rate 1? Jawapan dia boleh. Okay, provided you dah determine this one. Kalau you tak determine lagi, tak boleh lah. You kena pakai this method. Make sure that this one should be the same, this one should be kept constant, the other one should be varies. Ni you dah tahu. Satu-satu. Okay, ini je yang you nak cari. Masukkan value dia. Dia ada, maksudnya value dia banyak lah calculation yang you kena consider kat situ. Kan selalu kita cancel kan. Ini lebih senang lah. You cancel. And then you are left with this one only kan. Tapi kalau you nak pakai rate 3 and rate 2 for example, this one you dah ada value. You tak boleh cancel macam tu je. This one pun you ada value dah. You kena selesaikan mathematically. K yang boleh cancel. Ni semua masuk value. Okay. Itu lagi satu alternatif yang you boleh consider. So tak semestinya dia kena mesti sama. Dia mesti kena cancel. Itu paling senang lah. Ideally. Tapi kalau tak dapat, kita boleh go for another option. Provided kita dah determine the order. The other order lah. The other order. Except for the unknown. Okay. Alright. Last but not least. So you will get the Z with respect to H plus is equal to 2. The order of Z is equal to 2. And don't forget the rate law. Okay guys. Right, any question related to that before we proceed to unit of rate constant K? Anything?
Mila tengok tadi ya. Sekejap.
Madam, maksud Madam yang boleh pakai yang rate 3 dengan 2 tu maksudnya kena cari Z dulu jugalah.
Still kena cari Z. Still, kita memang misi kita nak cari Z kan. Sebab yang the rest are all known already kan. Kita dah tahu ni satu. Cuma you pakai rate 3 dengan rate 2. Bila you pakai rate 3 dengan rate 2, dia tak boleh cancel, betul tak? Ini boleh cancel sebab value dia sama. Betul? Ini kita cancel sebab value dia sama. And then after all dia kuasa satu kan. Kita dah determine. Macam biasa tu. Kan? Tapi bila you masuk rate 3, rate 2, value BRO3 minus dengan BRO3 minus untuk rate 2 dengan rate 3 tak sama, betul tak? Bila tak sama, maksudnya you kena solve mathematically. You kena consider, you kena darab lah nanti. So you akan ada value dia kat situ. Tapi whatever it is, unknown you sekarang ni ada satu saja. Kan? Bila unknown ada satu, bukan kita boleh selesai bukan macam biasa. Tak, saya tanya awak ni, ikut saya salah ke beritahu saya lah. Betul tak? Logiknya. Bila macam ni, yang senangnya hidup kita ni, bila begini, kita boleh cancel out, kita boleh cancel off terus. Sebab apa? Okay, cuba jawab. Sebab apa kita boleh cancel off? Sebab value dia sama. Ni dan ni sama. BR minus sama. Okay? Sebab tu kita buat cancellation ni, sebab kita pilih yang fix. And then yang kita nak cari tu yang kita ubah-ubahkan. H plus yang berubah kan. Sebab apa? Bila kita nak buat calculation, senang kita zap potong. Okay? Tapi itu cara yang ideal lah, yang best. Maksudnya kita boleh simply cancel. Tapi tak bermakna kita tak boleh guna another option. Okay? Apa masalah kalau kita pakai rate 3 dengan rate 2? Value dia dekat sini, katakanlah sini 1.0, sini 2.0 for example. Boleh cancel ke? Boleh potong ke? Tak boleh potong kan? Bila tak boleh, katakanlah sini, cuba tengok tadi sekejap. Kalau saya pakai berapa tadi? 3 dengan 2 3 dengan 2, okay, 3 dengan 2, 0.2, okay lagi, nice. 0.2, 0.2, ini nice, boleh potong, Alhamdulillah. Tapi, pergi mana pula ni? 0.2 dan 0.1, see? This one, alamak, ni 0.2. This one is 0.1. This one not a problem because we can cancel it out. But this one, we cannot simply cancel it out. Betul tak? Kita tak boleh cancel off this one. Sebab kita kena selesaikan mathematically. Sebab dia tak sama. Betul tak? So kita kena carry lah. Kita kena selesaikan. Kita kena masuk kat sini. Nanti kat sini, dia akan ada value 0.1. Jangan lupa darab 0.1 over 0.2. So the value dia kat sini. So, tapi matematik je lah kan. Kita macam nak selesaikan ni. Sebab at the end of the day, kita nak cari Z. So the rest are all known value. Faham tak? Itu yang leceh sikit lah bila pakai 3 over 2. Tapi it's doable. It's doable. Tapi provided the order for the other reactant should be known value. Okay? Faham tak? Okay tak guys?
Faham.
Okay, right? Any other question?
Madam,
Ya.
kalau dia bagi 3 reaktan memang kena guna 3 reaktan je. Tak boleh kita pilih macam BR minus dengan H plus je.
Maksudnya bila nak buat yang part ni ke? By right, kena. Sebab kita ni, this one, dah macam apa je ni. This one, kita bukan come out dengan suka-suka je. This is based on rate law. Rate law depends on the number of reactant present, betul tak? So the reason we have BrO3 minus, Br minus and H plus, the reason we have these three because they are all included in the rate law. So if you don't include BrO3 minus, for example, you just include Br minus and H plus. So akan ada question dekat situ. Kita akan ada query. Why didn't you include BrO3 minus? What's the reason you exclude the BrO3 minus in the rate law? Okay, itulah masalah. Walaupun kita akan cancel kan later kan, tapi properly, maksudnya proper way to represent the beginning part is to have this one. Later kita cancel tu, itu belakang cerita. Tapi first step, before we can cancel, this is how the original ratio looks like. Okay, so it's basically the same. This is the rate law. Nampak tak? Sebiji sama. It's just that the data come from experiment 4. This one come from experiment 1. Okay, so jawapan kepada soalan awak tadi, kena adalah. Sepatutnya proper way is to have all the reactants in it. Unless, okay, unless it is stated in the question that that particular concentration, the order is equal to 0. The order is equal to 0. So that's the reason you did not include the concentration in the rate law. Tapi dia mesti ada reason lah. Okay, so it would best for you to include the whole reactant in the rate law. Later kita cancel ke apa, itu another story. Tapi starting mesti macam tu. Okay? Tapi ada je student dia kadang-kadang dia cut short. Dia terus sini, dia terus buat ni. Dia cut short sini, dia terus buat ni. Okay? So yang dekat situ, kadang-kadang kita kena discuss lah among examiners nak accept ke tak accept ke kan. So saya beritahu awak the proper way so that kita tak payah kita nak discuss among examiners. Bila kita nampak jawapan awak, this is the right way, this is the proper way. Okay, bila kita nak discuss among examiners tu, nanti ada perdebatan dekat situ. Some lecturers may not agree to accept, some lecturers may agree to accept. So leceh lah kat situ. So do it the proper way. Okay? Right, any other question? Okay. Right, if there is no question, let's proceed to the next second method of determining the order of the reaction. Okay, all right. We can determine the order of the reaction with respect to the reactant by looking at the unit of the rate constant itself. Okay, consider this simple reaction, single reactant A forming A forming product. Okay, so we can write the rate law of this reaction as this. This is the general rate law for this reaction, okay, to the power of n. So n can be 0, n can be 1, and can also be 2. Okay, so macam biasalah yang ini kita tahu, okay. What if n is equal to 1? What would be the if n is equal to 0, okay, what would be the unit for the rate constant? Okay, macam biasa, paling cepat would be for you to memorize the unit of the rate constant. So if it's 0 order, it should be mole liter negative 1. Okay, the concentration, this is the unit of concentration divided by time. So time can be minute, time can be second, hours, days, or as long as it is time. Okay, as long as it describes the time. Or in short, if we can simplify this one, we can also represent the unit of K as ms negative 1. First order will be second negative 1. Second order will be L mole negative 1 S negative 1. So dia terbalik sikit dengan second dengan zero order ni, dia terbalik. Okay, dia punya mole dia negative 1, liter dia kuasa 1. Dia terbalik dengan zero order. Okay, so dia punya kalau in molar, it should be M negative 1, S negative 1. Okay, alright. What if, okay, madam, I have problem in memorizing formula. Okay, so what are my options? Okay, macam biasa, don't worry, you can derive the unit of the rate constant from the formula itself. Okay, let's say for example, if it is a zero order reaction, so the unit of rate constant for zero order reaction will be, kan dia kuasa kosong kan, so rate is equal to K kan, so this is the rate law. Okay, if we were to transform the rate ataupun convert the rate and the K in terms of its unit, so rate, the unit for rate will be molar per second. Remember delta concentration over delta T, okay, the unit will be molar per second because concentration over time. Okay, if we were to bring this up, then it will be ms negative 1. If we were to kembangkan this one, okay, expand this one, molar is equal to mole over liter, remember? Okay, over liter S negative 1. If we were to make it sebaris, then it will be mole liter negative 1 S negative 1. Okay, so you dapatlah unit dia. This is if the order of fraction is equal to 0. Okay, you kena imagine macam ni. Contohlah soalan bagi macam ni so kita kena tahu the order of the reaction. Ada macam-macam cara soalan boleh bagi the order of the reaction. One is by giving you the data just now, macam initial rate method kan. The data will be given, so you have to determine the order. So by using the initial rate method just now. Okay, secondly, alternatively, okay, the order can be given in terms of unit of rate constant. Maksudnya dia bagi statement, soalan bagi statement bla 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 bla, okay, and then dia bagi rate constant. Kan at the end of the day kita nak write the rate law, betul tak? Ingat, kita nak write the rate law, we need to determine the order. So how do we know the order? Okay, one of it is from the unit of rate constant. So soalan bagi the value of rate constant together with the unit. You must be able to determine from the unit of the rate constant, you must be able to determine what is the order of the reaction. Soalan tak cakap, dia just bagi unit of dia bagi value of the rate constant together with the unit. So you sendiri kena tahu, oh from this unit I know already, okay, this is first order, so you have it already. So now can you write the rate law? Yes, because you have determined the order of the reaction just now from the rate constant. Remember tadi? Okay, tu contoh soalan lah yang dia boleh bagi. Okay, and you can also derive the rate constant from, let's say if it is a first order reaction kan, so this is the rate is equal to K times A pasal 1 kan. Okay, transform everything ni into its unit. Rate, kita tahu the unit will be molar per second. Remember? MS -1 ke M over S ke, doesn't matter as long it represent the rate. Okay, it can be minute ke hours ke, doesn't matter. Okay, kita pakai contoh second lah. K, and then what is the concentration, the unit of concentration? Yeah, it is in molar or mole liter. Remember, mole per liter also represent the concentration. Okay, but what we want is the unit of rate constant, right? So transfer everything to the other side so that we will have the K only. So K, MS -1. Okay, M transfer the other side, dia jadi bahagi lah, betul tak? So dia akan jadi begini. Ini matematik lah. Ini matematik. Transfer to the other side. So M cancel out with M and we will get K is equal to S -1, which also equal to 1 over S. See? Sama tak? Sama kan? Okay. So, you may derive it from the formula of the rate law itself. Okay, so try to do it, try to derive on your own for second order reaction. You should get the same as this one. M -1, S -1. Okay, alright, so tak ada masalah, tak hafal. Even for me pun, saya tak hafal. Okay, but I don't see a problem in it because I can always derive from the rate law itself. Tapi bila tengok macam ni, sebab ada 3 je order kan, we can straight away memorize lah. Tapi kalau lepas ni saya dah nak kena ajar SEM 1, CHM092. So of course saya akan lupa yang ni kan. So macam mana, how do I come back to this rate constant? We can always derive. Always derive. Okay? Alright. Okay, so we are done with the second method. So we are going to move to graphical method. Ada soalan related to unit of rate constant just now? Guys?
Tak ada.
Madam,
Ya. Yeah.
memang yang cari constant ni tak ada contoh soalan ke?
Tak ada.
Sebab kan dia bagi produk tu kan reaktan tu satu je. Kalau reaktan tu banyak,
Reaktan tu banyak.
maksud order dia macam-macam. Tak boleh.
Reaktan tak, dia macam ni. Dia mesti overall order.
Oh.
Okay, overall order. Maksudnya kalau you ada banyak kan, you ada banyak reactant. Okay, you ada banyak, 3 reactant. Tapi 3 reactant tu dia bukan satu, dia bukan tengok setiap satu tu, dia tengok overall. Satu, katalah the first reactant kuasa dia punya order will be 1. Second reactant the order will be 0. Third reactant will be 0. So total order will be 1. So bila 1 you pakailah cara yang ni.
Madam.
Ya.
So basically dia kena kira yang single dulu first dua-dua tu and then just tambah je lah untuk total order kan?
Tambah untuk total order.
Yang macam
untuk determine the rate of constant, is it?
Betul.
Dia total dulu. I mean you kena tahu the overall order dulu. Faham tak? Ini okay.
Like sorry. Maksudnya macam like kan kita satu-satu dulu order untuk each reactants kan. Lepas tu untuk cari total order tu just tambahkan je lah kan.
Ya, betul. Kalau itu maksud awak tadi, ya betul. You totalkan the order, you determine the total order. Katakanlah the total order is 1. Okay, the total, mungkin dia 1 tambah 0. The total order is 1. So 1 will be kalau the rate constant for first order will be this one lah, ms negative 1. Okay, dia will be dia total order. Dia bukannya with respect to each reactor ni. Mungkin dia agak confusing kat sini lah kan, sebab dia tulis single reactant kan. Jadi what if kalau dia ada 3 reactant, patutnya dia kena tulis kat situ for the total order. Okay, so thank you siapa yang bring this up. Bagus soalan tu. Okay, this one with respect to the total order. So you have to total the overall order dekat situ. Bukan with respect to satu reactant je. Nanti pening. Ini ada first order, ini ada zero order. Dekat dalam satu rate law tu ada first, ada zero order. So nak pakai yang mana satu? Pening kan? Bukan macam tu. Overall order. Okay, tapi our limit is until second order lah. Kalau you total up 2 plus 1, you dapat 3 kan? 3 order 3 kan? Tapi kita tak belajar. Okay, kita sampai second order sahaja. Okay, alright. Any other questions? Bagus soalan tadi. Tak ada Alright, so let's move on to graphical method, integratory law. Okay, graphical method, of course, we are going to use the graph. You have to plot the graph. Okay, topic 1, we have a lot of graph that you may need to know, you may need to plot. Okay, and then all of the graph yang you kena plot tu are all equally important. Dia bukan yang ni penting, yang ni tak penting. Tak. Semua pun sama balance kepentingan dia. Okay, alright. So graphical method, or also known as integrated rate law. So this graphical method is actually based on the integrated rate law. So you are familiar with rate law, right? So basically the rate law will be integrated. Okay, so the rate law will be integrated so that we can get the integrated rate law. Okay, kita integration. Okay, kalau dalam bahasa Melayu kita panggil pengkameran kan. Kalau differential, pembezaan. Okay, so yalah, differential, remember yang delta tu, delta concentration over delta T. This is what we call differential rate, differential rate. Okay, jenis differential. Dia ada rate biasa, okay, tapi usually the rate is the derivation of this. Okay, alright. Okay, so earlier on, okay, at the beginning of the topic, okay, you have been introduced to differential rate law. Like I said, this is the type of differential rate law. This differential rate law describe how fast is the reaction. Okay, so basically you will be given the rate. So you ada rate dekat situ. This one is equal to rate, right? So you terus tahu rate. You boleh tahu rate. Okay, so it describe how fast is the reaction. And then before the integrated rate law, you have been introduced to rate law sebenarnya. Okay, differential rate law, and then you have the rate law. This one differential rate law, remember last time yang kita ada the relationship in the balance equation tu where we have coefficient 1 per is equal to, and then don't forget the negative, the positive. The negative represent the reactant, the positive represent the product, and then we can relate the rate. Okay, so that is differential rate law. And then next we have rate law. So in the rate law, we do have rate is equal to rate constant and concentration. So we have the relationship between rate and concentration. And so why do we need to integrate the rate law? Mesti ada missing yang tak ada di differential rate law dengan rate law yang menyebabkan we have to integrate the rate law. Okay, alright. So basically, rate law describe how long the reaction must proceed to reach a particular ataupun predetermined concentration. Again, like I said, kenapa kita kena integratekan this rate law? Apa yang tak ada in the rate law dengan differential rate law, then we have to integrate the rate law so that we can get that information. What is missing, guys? Apa yang tak ada dekat rate law dengan differential rate law ni? That we have to, integrate the rate law so that we can have that parameter, that function dekat situ. What is it? Apa agak-agak ni?
Tak tahulah.
Sorry?
Tak tahu.
Tak tahu? Try lah tengok apa beza dekat rate law tu. Rate law apa yang tak ada dekat rate law, and then dekat integrated rate law tu, cuba tengok contoh integrated apa yang ada dekat dalam formula integrated rate law that is missing in the rate law and also differential rate law. Tak payah tengok jauh-jauh pun, baca je statement kat situ. Dia ada tulis kat situ kan. Statement.
Formula concentration ke?
Partikel tempat.
Sorry, lagi sekali siapa cakap dulu tadi?
Siapa dah boleh bagi?
Apa dia? Taufik ke yang cakap?
Ni integrated rate law ni dia cakap proceed to reach a particular concentration ke?
Okay, we do have concentration in rate law.
Time ke madam?
Yeah. Time yang tak ada dalam rate law tu. Even in differential rate law ni, okay, in differential rate law, usually dalam nak solvekan problem, okay, dia terus bagi rate je siap-siap. Okay, rate maksudnya kita dah given the delta concentration over delta T is already given in one value kat situ. Adalah yang kita kena calculate from data sikit-sikit kan. Tapi we don't have the time. Dekat rate law pun kita tak ada time. Okay, so that is why time is very important. Time pun kita guna time to describe whether the reaction is slow ataupun fast. Okay, so we are missing that parameter. We don't have that parameter in rate law. Okay, and we don't have that parameter normally described in differential rate law lah. Differential rate law selalu dia bagi terus je value, betul tak? Kat situ. Ada kadang-kadang you have to calculate provided the information need to be given to us. If not, dia bagi rate je. How do we know? And we don't have the time given to us. So that is why we have one of the reason is to have the rate law being integrated is due to we want to know the time taken for the reaction, for the concentration to become let's say from T0 to T5 minute, what happened to the concentration? Okay, and the time taken. Okay, so kat sini time taken for a change of concentration. Kat sini pun cakap describe how long the reaction must proceed. How long? Okay, must proceed to reach a particular predetermined concentration, to reach a certain concentration guys. So time taken is very important. So integrated rate law ni, you can imagine that nanti later formula dia tu akan ada T dekat situ. Okay, alright. The rate law can be integrated to obtain an integrated rate equation. So once the rate law has been integrated, we would call it as integrated rate equation that links concentration of reactant or product with time, which we don't have this in the rate law. Rate law kita hanya ada rate dan concentration so far. Even though we may expand it ke later ke, but more information need to be given to us. Okay, for that. Tapi by using integrated rate law punya formula, we have the time in the formula. Okay, alright. Okay, so the fourth point we have here, okay, let's put this one on hold. Okay, let's KIV this one because yes, like what I've told you just now, you have to construct a graph, you have to plot a graph. But before you could plot a graph, you must be, to me lah, pada saya lah, you must be introduced to the integrated rate law first. Because if not, you akan whichever plot give a straight line determines the order with respect to A, right? Okay, if plot is linear for concentration versus time, then it is 0 order. If plot is linear for ln A versus time, then the order will be 1. Okay, kenapa dia nak concentration? Yang first one ni, kenapa nak concentration versus time? Secondly ni, kenapa nak ln A pula? Baru dia jadi kuasa 1. Baru dia jadi order 1. Yang kedua ni, kenapa nak 1 per A? Then dia become kuasa 2. Ataupun dia second order. Okay, the reason is because of the integrated rate law. You have to look at the integrated rate law, then this one will make sense. Okay, so that's why saya kata kita put on hold dulu. Saya nak introduce ke awak the integrated rate law for zero order, for first order, and for second order. Okay, alright, you need to be introduced to that one first. For me lah, saya rasa. Okay, this one also kita kena put on hold first. Nanti kita come back to this, but please remind me. Kalau saya lupa, habis lawak. Okay? Okay. Alright, so let's start with zero order reaction first. Okay? Alright, so as we know, the differential rate law, so this is the differential rate law. Okay? Alright, so this is the rate law. Remember, rate is equal to KA kuasa kosong ataupun K lah. Okay, alright. So if you transform this rate into differential rate law, this is how it looks like. Betul tak? Rate is equal to this. Okay, alright. When we integrate the rate law, maksudnya macam mana nak integrate? Nah, ini matematik lah. This is all mathematic. So when you integrate, that means you akan integrate this one. Ini kita dah kita potong kat sini, kita macam ni. You integrate this one kan? So mathematically, you can integrate kan until the end, and finally you will end up with this final formula. Okay, so I've tried this one last time, long time ago. Okay, and I've proven that finally saya buat sendiri the integration, and finally I came to this final formula ataupun final equation, and it is proven for zero order reaction. Saya buat untuk zero, first and second. Sekali je lah buat. Lepas tu tak buat lagi. Maksudnya saya just nak proofkan je. Okay. So you have to, those who are interested to know further on this integration, okay, you may refer from your textbooks, any textbooks lah. Okay. Ataupun tengok je dekat internet, Google. Okay. How did they integrate this differential rate law and the rate law here. Okay, alright. So kita cut short story tu, siapa yang tu boleh cari ya. Cut short story. So kita punya final formula is this one. Okay, alright. As you can see, macam familiar dengan sini dengan the straight line equation. Betul tak? The straight line panggil straight line equation. Y is equal to mx plus c. Okay, you integratekan dia macam rasanya 0t kan, macam tu kan. Ke saya terbalik ni? Macam tu lah. This one pun sama 0t. Alright. Okay, so that's why you end up ada t kat situ nanti. Okay, so the y is concentration of A at t time and x is t. So that's why when ini dah straight line equation punya, kita boleh tally kan, correlate with the straight line equation kan. Therefore, we can sketch a graph from this equation, based on this equation, betul tak? So y dia adalah concentration at t time. Okay, at t time means it can be at 5 minutes, at 10 minutes, at 100 minutes, doesn't matter. T tu, that's why dia letak T. Okay, you can decide for T later lah. Okay, and then the x-axis represent the T. Okay, and as you can see, it has a negative graph because the slope is negative here. We have negative slope there. So kita boleh predict that the graph will be going downward, straight line, but going downward. Okay, alright, so this is our intercept. Intercept A at 0. A at 0 ni apa? Dia keluar kat sini. Okay. A at 0 is the initial concentration ataupun T is equal to 0 ataupun initial concentration. Initial concentration. With respect to our question lah, ya. With respect to our question. So initial concentration can also be changed. Okay. It can be varies lah. Dia tak semestinya with respect to this one. Yes, A at 0 initial concentration is equal to C. Okay. Alright. So A at T time is the concentration of A at any time. At 5 minutes, at 10 minutes, you nak tengok concentration pada ketika tu ada berapa. Apa yang tinggal. So pada 5 minit. So check concentration berapa kat situ. Okay, that is what it meant by A at T time. Okay, so you boleh nampak so graph untuk zero order has negative slope. Okay. Then lebih kurang sama lah explanation dia for first order. Okay, alright. So you integratekan this one. This is for first order and you will end up with this formula. Nampak tak apa beza dia dengan zero order? Kalau first order dia ada ln. Okay, dia ada ln dekat situ. Ln A at T time is equal to negative KT plus ln A naught. Kalau kita equatekan ataupun correlatekan dengan Y is equal to MX plus C. So Y axis kita will be the ln A at T time. Okay, ln A at T time. And then X kita macam biasa T. Ln A naught will be the intercept. Okay, kan kita samakan dengan ni, YMX plus C. And then it will be a negative graph. Kenapa negative graph? Maksudnya going downward because it has a negative slope dekat situ. M is equal to negative K. So value K tu negatif. Value M tu pun sebenarnya negatif. Nanti kita akan dapat negatif cancel, kita akan dapat value K. Okay. So ini kita dah boleh baca lah benda ni. So graph U tu patutnya ke bawah. Jangan buat macam ni. Jangan buat macam tu. This is not the characteristic of first order reaction. This is wrong. This is the characteristic of first order reaction. Provided ini ln A lah. This is T. Okay, make sure that you are able to differentiate graph untuk first order, second order and zero order. Okay.
Kenapa yang first order reaction pakai ada ln?
Tu kena derive lah. You kena derive lah daripada sini. Okay. Bukan you kena derive, you kena integrate kan. The process is integration. Kalau you nak tahu kenapa dia ada lon kan, tiba-tiba kan, dia ada sebab due to this integration. Okay, rasanya you lagi terror dari saya kot pasal nak integrate ni masa matematik mesti belajar kan. Saya dulu pernah lah belajar tapi saya punya fokus in chemistry Tapi saya pernah belajar dan saya pernah integrate kan. Panjanglah cerita nak tunjuk belajar integration pula kat sini. Okay, sebab dia dah ada kuasa kat sini. Bila you integrate kan, it's like macam dia reverse kan. Integrate dengan pembezaan dia macam reverse kan. When you integratekan kuasa, bukan you kena tambah ln ke ataupun log ke, tak silap saya, ln lah sini. Okay, ada something to do with that lah. But if you want to know further, boleh refer. Buka je internet tu, tengok macam mana dia integratekan. And finally end up with ln in the equation. Okay, alright. So basically, you nampak tak apa beza? Kena hafal. Of course, kena hafal guys. Okay, so you mesti kena tahu what is the difference dengan zero order dengan first order tadi. Zero order, we don't have ln. But first order, we do have ln. Tapi the rest are all sama kan? Nampak sama. It's just that you tambah ln. Kat sini pun tambah dia pun sama, negatif dia pun sama. It's just that you tambah ln dekat situ. Okay? Alright. Sama, A at t time is A, concentration of A at t time. Maksudnya, whatever that is left after a period of time yang tinggal. Remember? A at t time maksudnya pada ketika tu you check how much of it is left. Okay. Okay. Kita skip sekejap ni. Kita pergi ke second order. Sebab dia bagi contoh and then dia lepas tu baru pergi second order. Tadi zero, first, tiba ada example and then second. Okay. So kita go through dulu all the integrated rate law. Okay. So far we have zero. We have first. Now second order reaction. Okay, alright, sama juga. So this is the rate, this is the rate law. This is rate is equal to this one, the rate law kan, KA kuasa 2. If the order is second order. So you integratekan this one, you will end up with this one. Jangan tanya saya macam mana boleh ni tak ada ln pula madam, kan dia ada kuasa kat situ. Try lah integrate dulu. Integrate. Okay, so dia somehow they end up with 1 over. Okay, basically dia punya susunan tu lebih kurang sama. It's just that for this one, dia ada slightly different. Okay, for second order, it will be 1 per. The placement of A at t time will be is still the same, A at t time as the Y. Okay, the time is X. The x-axis, represent the x-axis, 1 over A naught is the C. So, bila you kena construct graph, so T will be your x-axis, 1 over A at T time will be your y-axis. Okay? Alright, tapi dia beza kat sini, this one, see? Be careful, okay? So this is a positive graph. So second order has a positive graph, which is different than the zero and the first order just now. Okay, different So kena ingat lah pattern takut keluar objektif. Dia bagi graph, pilih yang mana represent the second order. Okay, so make sure that you remember lah, you memorize. Okay, alright. So from the formula itself, we can determine it directly. Okay, so it has a positive slope. That means the graph should be increasing. Okay, so this would represent the slope. Slope is equal to K. And this would be the intercept, 1 over A naught. Okay, alright, so this is the formula, guys. This is the formula. It's the same, it's just that they 1 over the concentration, and one thing, okay, the slope is positive slope. Okay, the value should be positive.
Bila yang zero dengan first memang slope dia negatif lah. Dia ke sebab ya.
Zero order and second, zero order and first order just now. Slope dia negatif.
Memang negatif je apa-apa pun.
Dia kalau the moment you tahu yang dia adalah zero order ataupun first order, one thing yang you kena bear in mind that if you were to determine the slope ataupun graph dia ke apa, you mesti dah ada you kena alert that you kena produce negative slope. Negative graph. Maksudnya ke bawah macam ni, bukan ke atas macam ni.
Oh, okey. Jadi macam mana saya kena order ni boleh jadi positif pula?
Sebab bila dia integrate kan, bila dia integrate, lagi sekali you kena lalu that process integration, and then bila you equate kan.
Macam mana negatif tu boleh tak ada? Macam mana kita integrate tu, negatif tu boleh hilang?
Dalam proses tu lah. Dalam proses tu dia hilang. Maksudnya masa penyusunan tu dah tak ada negatif. Okay? Kena buat dulu. Kena lalu proses tu dulu. Baru you akan find out, the negative is not there. Bila you susun ke atau kan, mesti akan ada arrangement. When you susun, the negative is not there. You try to put the AT dekat sini, A0 dekat sini, and then you rearrange, you akan dapat negative is not there. So dia dapat positive slope lah dekat situ. Okay? Sebab dia kan missing dekat sini. Kita akan, macam mana sini boleh positif kan? Saya pun tak boleh nak jawab unless kita kena go through the process dulu. Saya bukanlah matematik. Kalau orang matematik tu mungkin dia tahu kan, okay ni negatif. Kita boleh tahu ni dia mesti akan produce positif. Saya taklah pro sampai macam tu. Okay, saya pernah buat this one and I have proven that the integrated rate law is the same as what we have in the slides here. It's just that dia long time ago, many years ago, like 10 years ago kot. Rasanya saya first start serve UiTM, masa tu biasalah kita excited kan. We want to know more, we want to learn more, we want to know in detail. So kita study. So dah tahu sekali dah lah kan. Kita just nak prove kan dia punya formula tu. Kita dah dapat proof kan. Apa kita nak buat banyak-banyak kali. And after all, our focus is more on chemistry part, not on the mathematical part. That's why the most important thing is, it's not the integration process, it's the final formula. Okay, that's why siapa yang tak berminat nak tahu pasal integration, tak apa, you can just straight away use the formula. Siapa yang berminat nak tahu, then go ahead and find it in the internet. The easiest way will be from the internet lah. Okay? Alright. Okay, jom. Okay. Alright, so that one. Kita rewind balik. Kita buat contoh dulu lah example. This one kita ke IV dulu. Kita buat contoh dulu. Cuba kita buat contoh related to this order integrated rate law. Okay, so you have been introduced to the formula of integrated rate law with subject to zero, first and second. Jom kita tengok contoh soalan. Okay, so you boleh imagine tak? The most important thing is when you want to know which formula that need to be used. Kan kita ada 3 formula yang kita nak kena guna kan. So the most important thing you have to determine the order first. Kalau you tak tahu order, macam mana you nak tahu you nak pakai formula mana satu? Betul ke tak betul saya cakap ni? Cuba jawab sikit.
Betul.
Betul, madam.
Okay? Thank you. Okay? Lagi sekali saya ulang soalan saya. You kan dah belajar 3 formula. For zero order, for first order, for second order. Okay? So ni provided you dah tahu the order tau. You can straight away use the formula. Okay? That means you have to know the order first before you could use the formula. Okay, kalau you tak tahu order, macam mana you nak tahu you pakai formula yang mana satu? You tak tahu. So first thing first, if you read the question and you know that you have to use the integrated rate law, macam mana you tahu? Antaranya bila dia suruh calculate time. Confirm pakai integrated rate law. Okay, but one thing that you have to very sure of is the order of duration because it determines the formula that you will be using later on. So you boleh imagine tak bila you salah determine the order, so you salah pakai formula. So boleh imagine tak betapa dahsyatnya keadaan tu bila semuanya you salah. Sebab order you salah daripada awal sampai akhir salah. Okay, soalan itu yang kita agak scary sebab dia macam berantai. Itu yang scary part. Okay. Okay, jom tengok example. The conversion of cyclopropane to propene in the gas phase has a rate constant of 6.7 times 10 to the power of -4 as -1 at 500 degrees Celsius. Okay, and if the initial concentration of cyclopropane was 0.25 molar, determine the concentration of cyclopropane at 8.8 minute. Ini pun dah boleh nampak, okay, dia bagi concentration of initial, dia nak tahu concentration at 8.8 minute ataupun the concentration at T time. Kan A lah, maksudnya propane lah. This is propane, okay. This is integrated rate law. And then look at second question, calculate the time. Also integrated rate law. Time lagi, integrated rate law. Okay. It's just now, you have to know which integrated rate law that you should be using. So kita nak tahu dia ni integrated rate law berapa ni? Integrated law, order. What is the order of this fraction, guys?
First order.
Mana tahu?
Dia tulis
Rate
constant.
Rate constant. Ada tak dia beritahu this is first order? Dia tak ada lah, itu zaman kanak-kanak dulu lah baru dia nak beritahu directly macam tu kan. So dia akan beritahu tapi indirectly. So cuba imagine you lupa the rate constant ni unit. Takut nak imagine. Tak payah imagine lah. Okay, benda-benda negatif tu. Okay, alright. So from the value, from the unit of the rate constant, it shows that this fraction is a first order reaction. Is it? Yes. Yes. It's a first order reaction. Bila dah tahu first order, straight away tulis formula for integrated rate law for first order. So at least kat situ 80% you akan betul lah. You dah ada formula yang betul kan? Okay. Alright. So let's go for A lah. Okay. Cuba practice lah. What is the integrated rate law? So far yang kita dah tengok tadi, okay, cuba practice. Boleh tak tulis ln A at T time is equal to negative KT plus ln A. No. This is the formula. You ada ln Okay, this is for first order. Okay, alright. So, if the initial concentration of cyclopropane was 0.25, okay, this is the initial concentration. So we have this for this value already is given. Determine the concentration of cyclopropane at 8.8 minute. Dia kata determine the concentration of cyclopropane at 8.8 minute. That means T will be 8.8 minute. Dia ada kata convert into second ke whatsoever ke? Yes. How do we know? How do I know that we have to convert into second? Guys, how do I know?
Rate constant.
Yes.
Constant this second.
Very good. Okay? Because of the the unit of the rate constant is in second. Okay? So you have to convert this 8.8 minute into second. So imagine kalau you tak consider the unit, you can simply masuk value je lah. Okay, you can simply masuk value saja dekat situ. Okay, so make sure that you convert into second. Okay, and then you nak find out this one at 8.8 minute kan, ataupun add berapa ni. Tekan calculator je lah, carilah kan. Okay, alright. This one. Okay, so this is the values, ln kan dia, so you have this one. Okay, note that in the ln A0 term, A0 is expressed as dimensionless quantity. Dimensionless means no unit, unitless, okay? Because we cannot take the logarithm of unit. Maksudnya bila kita logkan something tu, kita tak boleh carry the unit. Okay, we cannot carry the unit. Macam ni lah. This explains why it is without the unit. Okay, tapi when you are calculating for concentration, you should know when you ln kan, mana ada kita carry dengan dengan unit-unit kan. Tapi when you are calculating for concentration, at the end you must make sure that you have to tambah the unit. Okay, you kena tambah the unit because when you deal with ln, log, those are dia different dengan kuasa. Kalau kuasa, kalau kita darab kuasa, maksudnya kuasa kan kita akan dapat min kuasa 2 macam tu. Tapi kalau log, ln dia lain. Okay? Okay, B apa pula soalan ni? Jauh ni. B. Calculate the time in minute for the concentration of cyclopropane to decrease from 0.25 molar to 0.15 molar. Okay, alright. So dia nak calculate the time. So nak calculate the time by using the same formula. Okay, same formula. So you want to calculate the time, the green one. So this is provided. So this is 0.25 molar still. And this is given 0.15 molar. Okay, alright. So we have only one unknown to be determined, so it shouldn't be a problem. So the time, the unit should be in second lah. Okay, alright. Then for B, how about C? Calculate in minutes the time taken to convert 74% of the cyclopropane. Okay. Still, we have to calculate the time. It's just that in terms of concentration lah, okay, this can be quite confusing kalau you salah faham. Okay, but first thing first, you are still going to be using the same formula, which is ln A at t time is equal to negative kt plus ln A naught. Okay, alright. So nak cari T kan? T nak cari, okay. Bila nak cari T, by right we should have these two information. Kena ada. We should have these two information. Okay, alright. So how do we translate the information that is given to us? How do we translate 74%? What does it mean by 74%? Okay, so you tak boleh translate directly macam tu. You kena faham betul-betul. What is A at T time? A at T time means the concentration that is left after a period of time. Yang tinggal tau tak? You imagine you buat reaction kan? You buat reaction. Okay, nak check lah. After 5 minit, berapa concentration Yang you check tu adalah concentration yang tinggal kan? You bukan check yang concentration dah hilang. You check concentration yang tinggal. Betul tak? That is what A at T times mean. Okay? Itu maksudnya yang tinggal. Bila kita tahu yang tinggal, kita boleh calculate for the one that has decomposed. Okay? Alright, so itu imagine kalau kita buat eksperimen. So you measure yang tinggal. Baca soalan balik. The time taken to convert 74% of the cyclopropane. To convert 74% of the cyclopropane. Adakah maksudnya 74 ni yang tinggal? Adakah 74 ni yang tinggal? Adakah yang tinggal, guys?
Tak.
Bukan yang tinggal. nak convertkan 74%, maksudnya yang 74% ni yang dah hilang. Maksudnya yang hilang untuk jadi produk. Okay. So yang dah decompose. 74% means yang hilang, okay, untuk jadi produk. So,
dah diguna lah ya madam.
ya, salah guna. Yang dah, dah digunakan untuk menghasilkan produk. Okay? So yang tinggal sebenarnya berapa? Dia nak convert 74%. So by right, at T time, yang tinggal berapa? Cyclopropane yang tinggal berapa? So, sepatutnya, so initially berapa? Initially it should be 100%. Betul tak? 100 over 100 will be 1. Okay, so at T time, again like I said, yang tinggal. So maksudnya 100 minus 74%. Berapa? 26%, betul tak? Divided by 100. So you akan dapat 0.26. Okay. Nak convert 74% ni jadi produk. So yang tinggal lepas 74% berapa? 0.26 cyclopropane sajalah yang what is left behind. Faham tak? So initial dia will be zero pula. Initial will be 1 sebab kalau kita when we use percentage, initial means sebelum digunakan, betul tak? So it will be 100% regardless lah dia 0.5 molar ke 1 molar ke, doesn't matter. Kalau dia belum digunakan, it will be 100% which is equal to 1. Okay, if 74% has been used, 74% of the cyclopropane has been used. So how many is left after T time? So it will be 26% yang tinggal. So convert into pecahan, jangan jadi dalam pecahan, jangan tinggal dalam percentage. Okay, so you convert 0.26 lah. Saya tak sure. Kalau you maintain kat sini 100, this one is 100, this one is 26%, maksudnya boleh juga. 100, this one 26. Tapi kalau you sini 100, this one you buat 0.26, tak boleh lah macam tu. Okay, but if you stick kat sini 100, this one 26, rasanya dapat jawapan juga. But ratio dia sama kan? If not, another option will be 1 dengan 0.26. Okay? Alright. See this one. Okay. Okay, ni cara dia. Boleh try buat lah. Okay, cuba kita tengok. Ada lagi tak? Cuba tengok example for second order reaction. Example for second order reaction before kita masuk graph. Iodine atom combine to form molecular iodine in the gas phase as shown in the equation below. The reaction has a rate constant of this. Dan baru tengok tadi kan, kita dah boleh terus hafal dah sebenarnya. M-1, S-1. Okay, if the initial concentration of I was 0.086 molar, calculate the concentration after 2 minutes. Okay, so what is the order of this reaction based on the unit of the rate constant, guys?
Second order.
Okay, very good. So it is a second order reaction. Siapa yang masih tak ingat lagi tu, pergi buka notes. Buka yang dekat rate, unit of rate constant tu. M-1, S-1. It will be second order. Okay. First order S-1 je kan. Zero order M-S-1. Yep. M-S-1. Aduh. If the initial concentration of, this one. So you have to use the Integrated Rate Law for second order. So what is the formula? Dah boleh hafal dah terus? Patutnya boleh hafal dah terus nanti So 1 per A at T time is equal to positive value, remember? Slope dia tadi, ingat K dia tu, dia je seorang yang positif. 0 and first order both have negative sign. Plus 1 A naught. Okay? If the initial concentration of I was 0.0. Ni apa masalahnya? Ini boleh masuk je lah. Ni kan the initial concentration. So you can insert into this 0.086 molar. Don't forget the 2 minute you have to change into second because why? We have the unit for unit rate constant is in second. Okay? Alright, so transform so that you can insert the K. You have to insert the K. Dia nak apa? Dia nak this one. Okay, A after 2 minutes. So time we have already 2 times 60 seconds will be 120 minutes. Is it? At 20 seconds. Okay, kita nak cari this one. Berapa? Okay. Okay, so basically this is how you calculate it. Okay, ini pun kita boleh baca The concentration, wow, the concentration is very, very low. Okay, at T time, after 2 minutes, just only after 2 minutes, the concentration, the concentration left is only negative. Very, very low guys. Very, very low. Maksudnya yang tinggal pada ketika lepas 2 minit tu adalah 10 kuasa negatif 12. Maksudnya apa? Rate of reaction dia sangat-sangat tinggi lah. Okay. So this is such a low concentration that it is virtually undetectable. Normally kuasa negatif 12 ni susah nak detect. Kita pun tak dapat detect. Kita akan detect dia sebagai zero je. Sebab kuasa, you imagine 1.0.00000 belakang 12 kali 1, 2. Okay, so the very large rate constant, sebenarnya kita boleh baca from the rate constant, very large rate constant for the reaction means that nearly all the atoms, all the iodine atom combined after only 2 minutes of reaction. So the rate of reaction is very, very high because you know, rate law is equal to K kuasa A. So when the K is higher, the rate should be higher too. Betul tak? Ni benda-benda macam ni kena pandai translate lah. Apa maksudnya bila you dapat the value kan? What does it mean? Bukan sekadar kira-kira je. Kena must be able to translate the value. Okay, chemistry, how do you explain the value that you get? It is very, 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 very low, right? So what does it mean? Okay, tu yang membezakan awak dengan bila you faham, you must be able to explain this. Okay, bukan simply just tekan calculator saja dapat jawapan betul. Right?
Oh madam, yang 0.086 M tu ni dia sama dengan 1 per A kosong tu
Ya, bukan this one A kosong ni is this one. Tapi maksudnya dia 1 per 0.086 mula. So you kena selesaikan lah.
Saya ingatkan 1 per A sama dengan 0.086.
Tak. Itu awak masuk dalam formula. Masuk dalam formula tu still remain the same. Yang ni value this one is only for this one. Dia cakap initial concentration je. Dia tak cakap 1 per A ke apa dia kan. Tahu tak? Taufik kan yang tanya kan? So be careful benda tu jangan salah translate. Ini baru formula and then you baru nak masukkan the value tu, baru nak isi yang mana yang related kan. So, tapi jangan salah translate, okay? Okay, dan sini dah habis kot contoh kita Okay, sekarang barulah kita nak pergi ke nak patah balik, jauh ni. Point number 4. Okay, alright. So Tadi, you perasan tak soalan-soalan, contoh-contoh soalan tadi? Dekat soalan, dia kena beritahu what is the order of reaction. Barulah kita boleh pakai formula yang sesuai. Faham tak? What if, remember, this is all about to determine the order of the reaction. Soalan-soalan yang kita buat tadi, soalan dah bagi tahu the order. Macam belum menyelesaikan nak determine the order tu kan. Itu derivation, terbitan, contoh-contoh soalan lah yang soalan boleh bagi. Tapi how do we determine the order by using this integrated rate law? How? Tadi dia bagilah, tadi dah bagi unit of rate constant kan. Maksudnya indirectly it's already given to you. Okay? Ini cara paling basic sekali. Maksudnya you have to work from scratch. How do you determine the order? By using this integrated rate law. You have to have the graph. You have to plot a graph. Okay, so dia punya key dia adalah, barulah you dah tahu kan kenapa dia A versus time. Kenapa ln A versus time. Kenapa 1 over A versus time. Sebab daripada integrated formula for zero order, okay, dia punya graph dia tu straight line punya formula tu dia tally kan, kita akan dapat concentration A versus time. Okay, untuk first order, you akan dapat graph dia tu ln A versus time. Betul tak? Y dengan X dia tu. Dia punya X axis. This is Y axis. This is X axis. This is if it is a first order reaction. This is if it's second order reaction. Yang Taufik tanya tadi, kenapa dia 1 per A tu. Okay, so this is second order. 1 over A versus times. X dia sama, time. Tapi dia punya Y axis different. Okay, alright. Ini dia bagi, okay, how do we know? How do we start? Okay, what is the question that can be asked related to this integrated rate law that requires us to plot a graph in order to determine the order of the reaction? Okay, macam ni. Soalan dia akan bagi macam ni Graphical determination of reaction order for decomposition of N2O5. Dia bagi reaction and then the concentration data is used to construct 3D. Bukan macam ni. Bukan kan. Ni soalan ni, ini just explanation. Okay, alright, dia macam ni. Tak ada pula dekat dalam tutorial awak ada. Okay, dia bagi equation dekat sini. Dia bagi equation dekat situ. Soalan tanya, determine the order of the reaction and then the data is given to you. Data yang dia bagi dekat awak hanyalah this one saja. Saya boleh refer tutorial later Alright. Ini saja yang dia bagi dekat awak. Okay, and then dia tanya determine the order of the reaction. The order of the reaction So far kita memanglah ada plot graph kan, ada kan, time dengan concentration ada, tapi itu kita nak tahu apa? Nak tahu rate. Remember last time yang first tu yang you kena plot graph tu. Dia bagi time, dia bagi concentration. That is for you to find the rate. Tapi soalan nak cari order, find the order. Okay, now it's different from the one that you've drawn, you've plotted last time. Lain sikit yang ni. Okay, so how do you determine the order? So this is by using integrated rate law. Okay, that means you have to prepare the data. Sebab you kena imagine, you tak tahu is it zero? Is it first? Is it second? Tak tahu. Okay, alright, so you kena prepare what if. Okay, alright, so kalau dia zero order, graph yang you kena buat apa? Concentration versus time. So you dah ada time, you dah ada concentration. Betul tak? Tak ada masalah. Okay, this one you can calculate for, you can plot the graph for zero order. And this one, you nak, what if kalau dia first order? Betul tak? First order. So kalau dia first order, you kena prepare data untuk ln concentration versus time. Again, time is there, but we don't have the ln concentration, but we can calculate the ln concentration by using the concentration given. Betul tak? Kita just simply lnkan dia lah. Dapatlah this value. Okay, and another probability would be, what if kalau dia second order? Second order graph dia macam mana? 1/A kan? Versus time. Okay, versus time. So you kena prepare lah data ni. 1 perkan dengan concentration. So you buat lagi 1 column dekat situ. Okay, dia punya dahsyat ni. Maksudnya, you kena prepare 3 graph. Okay, you kena prepare 3 graph. You kena plot 3 graph. And then from that 3 graph, you kena observe which one will produce a straight line. That's why lah kat sini yang term-term dia cakap, if plot is linear, then dia zero order. If plot is linear for ln A versus time, then it is first order. If you see, if plot is linear for 1/A versus time, then it is second order. That means you have to plot all the 3 graphs and you have to check, to observe which of these 3 graphs produce a linear graph. Okay, and contohlah dia dah buat lah kan. Okay, this is kalau if dia zero order. This is if dia first order. This is if dia second order. If. Dia plot, see, nampak curve, dapat curve. You don't want curve. First, nampak dia dapat straight graph. Second, dapat curve juga. Tak nak. Curve tak nak. Kita nak straight line. Kalau dia straight line tu, maksudnya graph tu represent the order of the reaction. Maksudnya ln versus T kan? Ln concentration versus T. Therefore, the order of the reaction is first order. Okay? So, banyaklah kerja dekat situ. Tapi normally kita jarang bagi soalan jenis-jenis macam ni lah. Kita rasanya tak pernah keluar that you have to plot all the 3 graph. Tak pernah keluar. Tapi kita akan bagi hint lain. Okay? That indicates that it is more on the first order rather than the zero and second order. Okay, tapi the one that you have in your tutorial, if I'm not mistaken, you have to construct 3 graph. Okay, that is just for your practice lah. Last time, so far setakat yang saya ni tak pernah kena buat 3 graph dalam exam. Banyaklah kerja kan, nak prepare graph itself tu pun requires a lot of time kat situ kan. Okay, faham tak? Ada masalah, cuba tanya soalan related to this.
Madam, kalau contoh awal-awal untuk zero order tu dah dapat straight line tu, kena lukis lagi ke? Yang first order dengan second order.
Itulah maksudnya awak bernasib baik lah kan. Terus maksudnya first mana ni aku nak try. Cuba aku try buat first lah dulu. Tu terus dapat. Okay. So macam mana nak cakap lah. Boleh lah kot. Saya pun tak pernah sebab we never prepare this kind of question, okay, for the exam. So tak boleh nak imagine dia punya cara marking dia macam mana. Okay, selalunya like I said, kita akan bagi indication lah. Ada hint-hint yang menunjukkan you have to draw for first order instead of the other order. Tapi itulah, tapi katakanlah keluar dalam you punya tutorial kan, niat kita tu, niat. Okay, for you to experience yourself. For you to experience yourself on how, ataupun practice on how to plot a graph. Lebih kepada itu sebenarnya. Sebab dia boleh keluar, dia boleh dekat first, dia boleh second, dia boleh zero. Okay, you nampak tak agak scary kan untuk law ni, dia punya bukan scary lah kan, saya lah mungkin sebab dah lama saya tak buat graf kan. Okay, dia punya tu adalah negative sign guys tu. Okay, and this one is 0, 0, 0, point, and then this one dia bukan point, dia nombor-nombor besar guys. Okay, so you must be able to be quick in terms of nak determine dia punya scales. So the more you practice by right, lagi ni lah. Itu niat dia lah. Okay, tapi kalau you rasa you confident, you tiba-tiba you serkap jarang, or you okay sajalah nak start dengan first order, sebab first and you confident, tak payahlah buat yang lain-lain. Okay, tak payahlah buat yang lain-lain tu. Dan you rasa next time kalau kok keluar second order, you don't have that experience tau. You tak ada that memory yang you construct untuk second order punya graph. Okay, so itu je. Dia more on the practice punya side lah. But as long as you can prove that you produce a straight line, then it's okay. Okay, tapi saya suggest untuk practice lah, practice. Okay, any other question?
Madam.
Ya.
Kan soalan-soalan sebelum ni, contoh-contoh sebelum ni, A tu refer kepada reactance. Tapi dalam notes point 3 tu dia cakap link concentration of reactance or product. Maksudnya A tu can be product juga.
Normally we don't go for product lah. Kita memang go for reactant. Okay, rate of reaction kita memang go for reactant. Itulah product tu mungkin kalau advance kot. Okay, so itulah. Tu pun saya perasan juga for product tu. That's why saya tak stress on the product lah. Rate of reaction, our focus is more on the reactant. Okay, any other question? Faham ya? Related to this. This is also very important. Lama dah tak keluar soalan ni dalam exam. Okay, so please be careful. Okay, jom. Mana lagi kita miss out tadi? This one settle. This one? Okay, alright. Katakanlah kan, okay, remember at the end of the day when you have a graph, when you have a linear graph, especially you have to calculate the slope. Slope mesti kena calculate, and how do you relate the slope dengan the integrated rate law? Okay, alright, so slope depending on the graph, the type of graph that you have, okay? Alright, so if you have a straight line for long concentration versus time, okay, alright, so later on you have to calculate the slope. So you must know that slope is also equal to K, negative K here. Nampak? Sebab this is M kan, mx plus C. Y is equal to mx plus C. So M is equal to negative K. So the value of M, the value of slope is negative, see? Bila you calculate kan, you akan dapat slope tu negative value. So you have this relationship, nampak ni? M is equal to negative K. M is equal to negative K. So K would be positive value lah. So negative, macam ni lah. Negative 5.7 times 10 to the power negative 4 as negative 1. So negative, you have positive value. Okay? Alright, value of K will always be positive lah. Maksudnya dalam rate constant, mana ada rate constant dekat kita punya rate law tu, mana ada dia punya negative value. Okay, so far all positive value. So make sure that you, okay, bila kena buat graph, confirm, especially kalau straight line, confirm mesti kena calculate slope. Okay, so subject to whatever courses that you in, you mesti kena relate kan. Katakan dalam chemistry, slope tu represent apa? In this case, it is rate constant. Tapi kalau subjek lain, bio ke apa, slope tu represent apa? Dia mesti ada interpretation of the slope. Okay? This is if dia first order. Kalau dia second order, so M will be is equal to K. Remember? Sebab K dia positif. Second order. Remember? Second order. Okay, ni apa lagi ni? See, ini contoh. Contoh soalan bagus. Ini sebenarnya saya nak tunjuk kat awak ni. Okay, example. Cuba tengok example ni. Ethyl iodide decomposes at certain temperature in the gas phase as in the following equation. So this is the equation. From the following data, determine the order of the reaction and the rate constant. Okay, the order of the reaction and the rate constant. So how is it from these data? Okay, from these data, you can obtain the order of the reaction. So like what I've shown to you just now, okay, you can assume what if dia zero order. So you kena prepare time dengan concentration. What if dia first order? So you kena ada ln concentration. What if kalau dia second order? You kena ada 1 per concentration. Ln kan aja dapat. 1 per kan concentration dapat. And then kena buat tiga graf sebenarnya. Kalau you malang, you try test untuk malang tak berbau. Bukan malang tak berbau, malang sikit nasib you. You try untuk zero order, you dapat curve. That means you kena proceed for first dengan second. Okay, macam biasalah dekat dalam ni. Kita tunjukkan yang indah-indah saja. Okay, kita tunjukkan terus je. Ln dengan time, terus dapat straight line. Sebenarnya tak semudah ini hidup tu Okay, alright. So you kena, sebenarnya you kena try out lah. You kena plot all the graph. Okay, alright. So ni, you kena prepare. This is the one yang produce the straight line. So it is a first order reaction. Then you have to find the slope because why? Slope represent the rate constant. Okay, slope represent the rate constant. So this is the slope. So m is equal to negative k. So your m is negative 1.4 times 10 to the power of negative 2 minute negative 1. Is equal to negative k. So what you want is k only. So you transfer this one to the other side. Okay. So you akan dapat cancel. You akan dapat positive value lah. 1.4 which is this one. Don't forget the unit. Rate constant you have to have unit. If not, markah tolak. Ke mana ni? Okay, any question related to integrated rate law just now? Okay, so obviously we are running out of time, but I want to give you a brief idea on what is half-life, okay, so that you akan dapat. So tomorrow kita boleh cepat sikit lah. Cepat sikit. Okay, ada soalan je? Ada? Semua okey ke? Ke pening? Ke apa? Ada ke? Please respond. Clear, madam. Zahin responded. Clear, madam. How about the rest? We have 40 of you in the session. So takkanlah satu saja yang bersuara.
Okay, madam.
Okay, madam.
Okay, madam.
Alright. So balik. Mungkin this is a lot for you guys. Balik. Cepat-cepat buka. Jangan tunggu lama-lama. Okay. So kena score punya midterm test Kena. So kalau ada problem starting from now, bukan starting from now, you ada problem je, try to solve for it. Cari dulu kat internet, mungkin boleh baca-baca, tanya kawan ke apa ke, tak faham juga, okay, tutorial tanya. Hentam madam. Tak ada orang hentam saya pun. Okay.
Madam,
Ya.
tutor ni tak payah buat Saya tak.
Habis manjang dia tak ada kelas. Okay. Kena lah. Okay, S14 dia punya cabaran dia tinggi sikit kali ni sebab dia punya tutorial on Monday. Okay. So kena lebih bersedia. Saya pun tak larat sebenarnya. Bila saya dah bagi lecture ni, sebenarnya kepala saya berat sangat.
Oh, tu saya pun berat agak ni.
Tapi tak apa, kita ada 1 hour, kita rehat. Saya lepas ni nak tidur kejap nak rehat. Aduh, beratnya kepala saya. So by the time saya tidur tu pun awak pergi berehatlah kejap. Tapi jangan tidur lama sangat. Mungkin 10 minit je ke, cukup lah. Lepas tu tidur balik. Okay, tak apa, kita cuba yang mana yang ni. So
Madam, waktu ni madam nak yang 488 ke question?
sampai yang kita tak belajar tu, kita akan buat there and then. So itulah cabaran S14. Maksudnya yang kita baru belajar kan, you baru belajar ni kan. Okay, tak apa, kita akan cuba buat there and then. You kena buat time itu juga. Kalau you tak dapat buat, saya akan tanyalah. So dia agak mendebarkanlah sikit pada ketika itu. So that's why you have to prepare earlier lah. S14. Okay, so saya akan try to macam tu lah cerita ni. Okay, cuba. Tak apa, kita cuba dulu. Boleh je, insyaAllah dengan madam ni lambat discuss apa semua kan. Tapi kita ni lah. Tak boleh juga lambat discuss nanti tak habis pula. Risau pula saya lah. Dah lah. Okay, so kita cuba dulu. Taufik and the rest and S14. Okay, half-life method will be the last the last one, okay, that we can use to determine the order of reaction. So half-life method, nama pun half-life kan. Half-life maksudnya separuh. Separuh apa? Separuh hidup. Lebih kurang lah. Tapi dia nak menunjukkan T sebenarnya. T half. Okay, half. Apakah T half? Maksudnya half. Bila kata half of apa? Okay, half of apa? Half of its initial value. Kita ada initial kan? Okay, so 0.5. Separuh daripada 0.5 will be 0.25. Ni kita panggil time taken for 0.5 to become 0.25. This will be T half. Okay? Alright, so macam biasa kita ada zero order. We have first order half-life, we have second order punya half-life. So of course lah kita akan ada dia punya formula. Okay, alright, so standby untuk esok. Kita akan ada, this is for zero order. Next we have second order. This is for first order. The formula, okay? The formula. Look at the formula. So this is the formula for zero order. Sebenarnya macam mana dia dapat begini? Sebenarnya because this one is derived from the integrated rate law. Remember integrated rate law, we do have T, right? So sebenarnya kita masukkan this one dekat A at T time. Kita transform because we already knew that what we want at T time, it should be half of the initial value. So this, you masukkan this one dekat dalam the formula. So you will end up, you susun, you transfer, yang mana you arrange, you akan dapat this one. This one also saya dah proofkan macam mana at the end dia dapat T half is equal to this. If you are interested again, you boleh find out. Okay, formula tu dia takkan datang tiba-tiba. Dia mesti ada induk punya formula. From there, dia derive. Okay, siapa yang tak interested, then just go ahead, memorize the formula. Okay, alright. So later kita akan tengoklah graph tu. So that will be the zero order. This is for the first order. And this is for the second order. Okay, the relationship and whatnot kita cover tomorrow. Okay, so that's the brief idea on what is half-life method. Okay, the time taken for the initial concentration to be half. The time taken. So that is what we call half-life. Okay, and we have the formula for each order. Okay, guys. Alright, so that is all for today. Any question? Tak apalah. balik cari dulu question tu. During tutorial, tanya soalan. Okay? Alright. Okay, rasanya itu saja. So thank you everyone for your attention. Okay, so we'll see you again tomorrow. Okay guys, bye-bye. Assalamualaikum and all the best. See you S14 later.
Thank you,
Thank you,
madam.
madam.
Thank
you,
you,
madam.
madam.
Thank you, madam.
Thank you.
madam.
Okay.
Ke ilmu, madam.
Yeah.